in today's lecture, we will be continuing section 1.6, right? But this time we will be talking about section 1.6.4, which is solving radical equations and equations with rational exponents. Right. So first of all, what is a radical equation? It is an equation with one or more radicals containing a variable. Okay, so for example, it is the cube root of x equal to 5. So that is a radical equation. Right. When it comes to radical equations, it is necessary to check all potential solutions in the original equation because some or all may not be solutions. And then when they're not solutions, they are called extraneous solutions. Right. We have steps to solve a radical equation, and we will go over them as we're doing examples. Right. So let's start off with the first block of examples. Right, our directions say solve for the variable, where the variable is a real number. Alright, so, with number 1, we are given the square root of w plus 3 minus 1 is equal to 4. Right, so step 1, says isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. So in our equation, we just have one radical, right? So this is the radical we have to isolate, right? So it's like solving for x, right? If we want to get x to by itself, it's like that. We just want to get the square root by itself. So in order to do that, we have to add 1 to both sides. When we do that, we're left with 5, right? Step 2, it says raise each side of the equation to a power equal to the index of a radical. So what is the index? The index is this. This is the index. And so when there's no index, so when you have something like this, that means n is 2, right? So that's just the, like for example, when you see x, what's the coefficient? 1, and then when you don't see the exponent, it's 1. Right? Same thing with a square root. It's when n is equal to 2. Right? So what am I going to do for step 2? I'm going to do it in red. So in here, so since the index is 2, I'm going to raise both sides by 2. Right? So why do we do step 2? Like, why is it like that? So let me go back over here. So I have x to the n. This is the same as saying x to the 1 over n. Right? And then our goal is to get rid of that square root. Our goal is to make the exponent 1. Alright? So it's kind of like, what do we multiply to make this just x to the 1? Right? So on Alex, it explains, I forgot what it's called, but essentially if you have the same base, right, then you can say A is equal to B. Right, A is equal to B if x to the A is equal to x to the B. Alright, so they have the same base, so then this would be 1 over n times A is equal to 1. Alright, we want to solve for A. Even better, instead of a variable, I'm just going to use a shape. We just want to fill in this blank, so I'll just call it a box. In order to do that, so if I want to get box by itself, I'm going to multiply both sides by n. When I do that, I get box is equal to n. Alright, so it says raise each side to the equation power equal to the index. As you can see, the index is n, right? And then in the box that we have to fill, it's n, right? Which makes sense, because if I have x to the 1 over n to the power of n, this is x to the n over n, which is equal to x to the first. Alright, so that's why we do step 2. When we apply step 2, right, we get w plus 3 is equal to 5 squared, which is 25. Technically that was step 3. We solve after we square it. Oh, sorry. No, That was step 2. Okay, now step 3, we want to solve for the variable. So subtract 3 from both sides, then I get W is equal to 22. Right, so we don't have to repeat steps 1 and 2 because we do not have any more radicals. Right, so now step 4, we have to check the potential solutions in the original equation. Right, so before I do step 4, I do want to make a note. In solving radical equations, extraneous solutions commonly occur when raising both sides of the equation to an even power. So we did raise it to an even power, so it's even more critical that we check our solution. Right, so step 4. Okay, we're going to plug W into our original equation, so this is going to be 22 plus 3 minus 1. Does this equal to 4? Right, then, so hold on, this is check. So this is square root of 25 minus 1. Does this equal to 4? Then we have 5 minus 1. Right, so we have 4 is equal to 4. Right, since this holds, all right, since there is no contradiction, what does that say? That says that our solution is W is equal to 22. Right? So now let's do the second example. The second example, right, we are given the square root of AH plus 1 minus the square root of 4H plus 9 is equal to 0. Right? So step 1, we want to isolate the radical. And then if an equation has more than one radical, choose one of the radicals to isolate. So in this case, we have 2 radicals. All right, I'm going to isolate this one, all right, because all I have to do is add the other one. Right? And actually, okay, when I add the square root of 4h plus 9 to both sides, we get this. Okay, so technically when we have 2 radicals and there's no constant, right, we're going to both of them end up getting isolated. So now we're going to raise each side of the equation. So step 2, we want to just get rid of that, we want to get rid of the radical. How do we get rid of it? We're going to square both sides, right? Remember, when we don't see an index, the index is automatically 2. Right, so when I do this, I get 8h plus 1 is equal to 4h plus 9. Right, I'm going to subtract 4h, then I get 4h plus 1 is equal to 9. And then I'm going to subtract 1 from both sides, then I get 4h is equal to 8. Right, divide both sides by 4, I get h is equal to 2. Right, now we have to check it. Okay. So we're going to so wherever I see an h, I'm going to plug in a 2, so I get 8 times 2 plus 1 minus the square root of 4 times 2 plus 9. Does this equal to 0? Right? 16, so 8 times 2 is 16 plus 1 is 17, and then 4 times 2 is 8. 8 plus 9 is 17. Right? So there's a square root of 17 and then minus square root of 17. So what does this tell us? This says we can subtract them. Right? We can subtract these because they're like terms. Right? This is 1 square root of 17 minus 1 square root of 17. So when we subtract, we get 0. Right, so since this holds, what does this tell us? This tells us that h is equal to 2 is our solution. Right, so what I have decided to do differently is I gave you guys the, so this y is equal to 57. This should not be here. So that was my mistake. Whoops. All right, but these 4, they're the solutions. So if you want to work ahead, here are the solutions. Right, so you know if what you did was right or not. But now let's continue on to the second block of examples. Right, so I'm going to use a different color. I'm going to use orange this time. All right, so same thing. All right, we still want to solve for the variable, right? But these are just a little bit different scenarios, right? So first things first is we want to make sure to isolate the radical. All right, so I'll explain why we want to isolate it in a little bit. Right, so but our radical is already isolated, so what are we going to do? We are going to square both sides. All right, we want to get rid of this radical. In order to do that, I'm going to take it to the power of the index, and the index is 2 in this case. Right, so when I do that, I get 10x minus 9 is equal to x squared. Right, so I have an x squared and x and a constant. What does that tell us? That tells us that this is a quadratic equation. Right, so we have to let one side equal to 0. Okay, I'm going to look at the leading coefficient. In this case, it is positive, so that tells me I'm going to move the terms, okay, the other terms to the right. So I'm going to subtract 10 from both sides and add 9 to both sides. When I do that, I get x squared minus 10x plus 9. Right, now we can factor. We want to find two numbers that multiply to be positive 9 and add to be negative 10. That'll be x minus 9, x minus 1. Right, now we can use the zero product property. So this is x minus 9 is equal to 0, or x minus 1 is equal to 0. Okay, so I get x is equal to 9, or x is equal to 1. Right, so now we're going to check. Okay, so we're going to check x is equal to 9, right? So we have the square root of 10 times 9 minus 9. Does this equal to 9? Okay, so 10 times 9 is 90. 90 minus 9 is 81. Does this equal to 9? The square root of 81 is 9 because 9 squared is 81. Right, so 9 equals 9. So we know that x plus 9, or x equals to 9 is a solution. Now we have to check x is equal to 1. When I do that, I get the square root. So we have 10 times 1 minus 9. Does this equal to 1? Right? So I have 10 times 1, which is 10. 10 minus 9 is 1. Okay? If the square root of 1 is 1, because 1 squared is equal to 1. Right? Since 1 is equal to 1, this is also a solution. So what does that tell us? That tells us x is equal to 1 and 9 is a solution. All right. Now, let us do the second one. Okay, we'll see what this light blue looks like. All right, so I'm going to solve 2 minus y is equal to 3 minus y plus 3. All right, first things first, we want to isolate a radical. All right, so luckily for us, the left side is already isolated. So what are we going to do? We're going to square both sides. Right, and when I do that, I get 2 minus y. All right, and over here, right, this is a perfect square trinomial. Okay, so, and then this is also why we want to isolate the radical. Okay, because, like, for example, if you didn't isolate in example 1 or example 2, you would have to end up foiling. Right, and then just, it would make things a little more complicated. Okay, but in this case, we isolated it. Okay, we can't isolate this one, so we have to, there's no choice but to foil. But that is the main reason why you do that, because of with these ones, if we didn't isolate, then, oops. Yeah, if we didn't isolate, then we'd have to do more. Okay, like for example, what we're going to do now. So this is, remember, so a minus b quantity squared, this is equal to a squared plus, oops. I'm just going to say a plus b because a minus b is the same as saying a plus minus b. Okay, so I'm just going to say plus 2ab plus b squared. Right, just make sure with the minus you have to keep the sign. So 3 squared, this is going to be 3 squared plus 2 times 3 times negative square root of y plus 3 plus negative the square root of y plus 3 quantity squared. Okay, let's simplify the right-hand side. So I'm left with 9. Okay, 2 times 3 times this negative 1, this is negative 6. And then this y plus 3, the square root of y plus 3. Okay, and then the negative square root of y plus 3 quantity squared. Okay, this is going to be negative 1 squared, and then this is the square root of y plus 3 squared. So we're left with positive y plus 3. Right. Let us simplify. So I have 2 minus y. Okay, I have 9 plus 3, which is 12. Okay, minus 6 square root of y plus 3 plus y. Right, so notice, okay, this is the first time we're encountering this, is for step 3, notice it says if the equation still has a radical, repeat steps 1 and 2. Our equation still has a radical, so we must repeat steps 1 and 2. Okay, so what are we going to do? I'm going to subtract y from both sides and subtract 12 from both sides. When I subtract 12 from both sides, I'm left with, when I subtract 12 from both sides, I'm left with negative 10. When I subtract y from both sides, I'm left with negative 2y. Okay, now what's negative 6? Y plus 3. Right? You could make sure, okay, this has a coefficient of positive 1. It doesn't matter as long as you know if you have like the a times the square root of like, c quantity squared. This is going to be a squared times c. Okay? Because the square root squared is just c. All right, so let's do that. I'm going to take the squared to both sides. Right, and the main reason why I'm doing this, so why am I not dividing both sides by 6, is because I'm going to get fractions, and fractions are gross, so we're going to avoid them as much as possible. Right, so let's go ahead and FOIL this. So again, this is a perfect square trinomial. So this is negative 10 quantity squared plus 2 times negative 10 times negative 2y plus negative 2y quantity squared. Right, and this is going to be negative 6 squared, and this is the square root of y plus 3 quantity squared. Right, this step was just to show you all the calculations that we're doing. All right, you don't have to write this step. You can immediately go to the one I'm about to write. This is 100 minus 20. Oops, sorry. No. Oh gosh. 2 times negative 10 times negative 2, that is a positive 40. And then there's that y. This is plus 4y squared. Okay, negative 6 squared is 36, and this is y plus 3. Right? So I notice this is a quadratic. Okay, so I'm going to first of all, I'm going to distribute this, and on top of distributing, I'm going to rearrange the left-hand side in descending order. So this is going to be 4y squared plus 40y plus 100 is equal to, and then we have 36y plus 36 times 3, 18. This is 108. Right, so we have 4y squared. If we subtract 36y from both sides, we are left with 4y. And then if we subtract 108 from both sides, we're left with negative 8. Right, I notice every term has a 4 in common, so I'm going to factor that out. So I'm left with y squared plus y minus 2 is equal to 0. Right, if I divide both sides by 4, we're left with y squared plus y minus 2 is equal to 0. Okay, when I factor, so we want to find two numbers that multiply to be negative 2, add to be positive 1. That's going to be y plus 2, y minus 1. Right, applying the zero product property, we have y plus 2 is equal to 0, or y minus 1 is equal to 0. So then we have y is equal to negative 2, or y is equal to 1. Alright, now we must check our solution. Alright, so what was our original equation? So this is going to be the square root of 2 minus negative 2. Is this equal to 3 minus the square root of negative 2 plus 3? Okay, this is when y is equal to negative 2. Right, so 2 minus a negative 2, this becomes 2 plus 2, which is 4. Does this equal to 3 minus negative 2 plus 3? That is 1. The square root of 4 is 2, because 2 squared is 4. Does this equal to, and then 3, square root of 1 is 1. Okay, so I get 2 is equal to 2. Alright, so we know that y is equal to negative 2. Excuse me, that is a solution. So now we have to check y is equal to 1. Okay, so square root of 2 minus 1, does this equal to 3 minus the square root of 1 plus 3? Okay, we have the square root of 1. Does this equal to 3 minus square root of 4? Alright, square root of 1 is 1. Does this equal to 3 minus the square root of 4, which is 2? Okay, 3 minus 2, that's 1. These are equal. So that also says y equals 1 is a solution. So, therefore, y is equal to negative 2 and 1. Right, and that is our solution. Okay, so now now let's do a couple more examples. Okay, so all the examples that we've done so far is when our index is equal to 2. Now let's see what to do when our index is not 2. Okay, so we have the fourth root of x is equal to 2. Alright, so same rules apply. Okay, we still want to isolate the radical. Luckily, our radical is already isolated. So now we want to get rid of this radical. In order to get rid of it, okay, I have to multiply, or I have to take the power to the index, right, which is 4. Okay, so because this is x to the 1/4, if I multiply this by 4, I get x to the 1. Right? So when I do that, so this becomes x, and then 2 to the 4th. 2 to the 4th is 2 times 2 times 2 times 2. In that case, that is 16. Right? And for this one, this is it. So now we have to check it. Okay, I don't have to put x equal to 16 because that's the only one I have to check. All right, but when you have to check multiple solutions, you have to tell me which y or which potential solution you are checking. All right, make it very clear. So let's check this one. Okay, so I have the fourth root of 16. Does this equal 2? All right, so for the fourth root of 16? Okay, so I should look up the definition, but like what I said, like for the square root of 16, this is equal to 4 because 4 squared is equal to 16. So when I have the fourth root of 16, does this equal 2? Right, so we're looking for something, so something to the fourth is equal to 16. Right, so the best way to actually check this one, actually, never mind. Okay, so, so the fourth root of 16, so this is 2, because 2 times 2 times 2 times 2. 2 to the fourth is equal to 16. Right, so the 2 is equal to 2. This is a solution. Right? Alrighty. So now let's do the final example. Okay, the final example I want to go over is the fourth root of u is equal to -3. Okay, so let's go ahead and solve this. All right, so again, we are going to take the fourth exponent, the power of 4 to both sides. Right, when I do that, I'm left with u is equal to -3 to the fourth. Okay, that is 81. Okay, so now we have to check. When we check it, okay, we're asking the fourth root of 81, does this equal to -3? Right, so if you look at 3 to the fourth, it is equal to 81. Right, but when you take so when you check this, okay, so the fourth root of 81, okay, that is 3. But 3 is not equal to -3. Okay, so what does that mean? This is no solution. Okay, so you could have solved this, all right, and then you could have checked it, and you could have came to the conclusion, right, because the fourth root of 81, it is a +3. Right? And then so this is a contradiction. 3 can never equal -3. However, if you recognize that if you have anything, so for a fourth root, okay, the number inside always has to be positive. Right? If it's negative, like so if I say like the fourth root of -1, right, this is I. Okay, maybe that's not a good example. This is I don't know, say -16. All right, I would pull out that negative, so this is this would be I, and then the fourth root of 16, right, which would be 2I. Okay, so this one, if you have a negative number under a even root, okay, then you're never going to get a real number. So if you recognize, all right, so if you recognize that all your solutions, so every number that is under u that has to be positive, right? If you ever say is equal to a negative number, you can automatically say no solution. So for example, if I say the fourth root of I don't know, like k, and I say this is equal to I don't know, -1. Okay, no solution. Can never happen. Right? Yeah. Alrighty, so that is it for today.